Why Germany lost. The 1944 oil crisis and logistics failure. Part 1. The lifeblood of war. The year is 1944. Across the shattered landscape of Europe, the Third Reich's once unstoppable war machine sputters, stalls, and begins its final descent into paralysis. German tank commanders rage at immobile armor. Luftwaffe pilots watch pristine aircraft sit unused on airfields. Infantry divisions wait for trucks that will never arrive. The Wehrmacht, which had conquered most of Europe in a stunning display of mechanized warfare, now faces an enemy more implacable than any army: the absence of fuel. Modern warfare demands oil. This truth, self-evident to military planners by the 1940s, had become the central fact of strategic calculation. Tanks consume fuel at prodigious rates. Aircraft burn through it with every mission. Trucks require it for every mile of supply transport. Naval vessels cannot move without it. Even the production of ammunition, the smelting of steel, the manufacture of weapons, all depend on energy derived from petroleum. By 1944, Germany faced a crisis that no amount of tactical brilliance, no superiority in weapons design, no courage of individual soldiers could solve. The Wehrmacht was running dry, and everyone from Hitler in his bunker to the lowest private on the Eastern Front knew it. Germany entered World War II with a fundamental strategic weakness that military planners understood perfectly but could never overcome. Unlike its enemies, the Third Reich possessed almost no natural oil reserves within its borders. The geological lottery had not favored Central Europe, while the United States pumped millions of barrels from the oil fields of Texas, Oklahoma, and California, while the Soviet Union drew from the ancient and abundant fields around Baku, while Britain could import from Persia and the Middle East, Germany scrambled desperately for every drop of petroleum. The numbers were stark and unforgiving. Before the war, Germany consumed approximately 44 million barrels of oil annually to maintain its peacetime economy and limited military forces. Domestic production from small fields scattered across the Reich? Barely 3 million barrels per year. The gap between consumption and production was not merely significant, it was catastrophic. Germany's entire industrial civilization, its transportation network, its agricultural machinery, its emerging military power, all relied on imports from foreign sources: Romania, the Soviet Union before 1941, Venezuela, and American oil companies operating through neutral countries and complex commercial arrangements. When war came in September 1939, these channels began to close. The British blockade, though imperfect, immediately restricted tanker traffic. American companies faced political pressure to cease exports to Germany. Neutral countries found themselves squeezed between belligerent demands. The Reich's oil supply contracted precisely when its military operations demanded massive increases in consumption. The Nazi response combined ambition with desperation. Synthetic fuel production on an unprecedented scale. German chemists had developed processes to transform coal, a resource Germany possessed in abundance, into usable gasoline and diesel through hydrogenation and other complex chemical procedures. The Fischer-Tropsch process and the Brilliance process became household names among German industrial planners. By 1943, massive synthetic fuel plants dotted the German landscape, concentrated in the Ruhr Valley, Silesia, and other industrial regions. These facilities produced roughly 5.5 million tons of synthetic fuel annually, representing an extraordinary commitment of resources, expertise, and industrial capacity. The synthetic fuel program represented both technological achievement and strategic vulnerability. The conversion of coal to liquid fuel consumed enormous amounts of energy, required constant supplies of coal transported by an already strained railroad system, demanded specialized equipment that took years to manufacture and install, and needed skilled workers who might otherwise contribute to weapons production. The plants themselves were massive, complex, and fragile. The hydrogenation process operated under extreme pressure and temperature. Specialized equipment, precision engineering, and careful maintenance kept the system functioning. Most critically, these plants became obvious targets, and their concentration in specific industrial regions made them easy to find and difficult to defend. A synthetic fuel plant could not be hidden, could not be moved, and could not be easily repaired once damaged. German planners understood this vulnerability from the beginning, but geography and technology offered no alternatives. Romania's Ploiești oil fields became Germany's single most critical petroleum lifeline. Located north of Bucharest, these aging but still productive facilities pumped approximately 10 million barrels annually by the early 1940s, representing more than half of Germany's total oil supply from all sources. Romanian oil flowed through refineries, into rail cars and river barges, northward into the Reich's fuel distribution system. Every barrel from Ploiești meant another week of Panzer operations, another month of Luftwaffe missions, another season of resistance against the gathering Allied forces. German troops occupied Romania partly for strategic geography, partly for political alignment, but primarily to secure this absolutely vital resource. Romanian cooperation was purchased with weapons, political support, and participation in the invasion of the Soviet Union. Romanian soldiers fought alongside Wehrmacht units partly out of ideological alignment, partly from fear of Soviet expansion, but the underlying transaction was always oil for protection. The mathematics of Germany's oil crisis were brutal and inexorable. The Wehrmacht needed approximately 20 million barrels annually to sustain full-scale military operations on multiple fronts. This figure assumed moderately intensive combat, regular training for replacement personnel, naval operations in the Atlantic and Mediterranean, and sufficient reserves to handle unexpected demands. By 1943, Germany's total oil production from all sources, Romanian imports, synthetic fuel plants, scattered minor domestic wells, and captured Soviet facilities still operating, barely reached 15 million barrels annually. The deficit grew every month. German commanders at every level made impossible choices daily. Fuel allocations became weapons in themselves, determining which units could operate and which would sit idle. The Luftwaffe initially received priority, consuming vast quantities to maintain air superiority over occupied Europe. Then those allocations were cut as losses mounted and the strategic situation deteriorated. Panzer divisions, the spearhead of German offensive power, sat immobile in reserve positions while Soviet armored forces advanced, simply because no fuel existed to move them to the front. Naval vessels remained tied to docks, their crews frustrated and idle. Training flights for replacement pilots were canceled or severely curtailed, leaving rookie aviators woefully unprepared for combat against experienced Allied flyers. The Eastern Front consumed fuel at catastrophic, unsustainable rates. Operation Barbarossa, launched on June 22, 1941, represented Germany's greatest gamble. That quick, decisive victory over the Soviet Union could be achieved before logistics became critical. The operation plan assumed the Red Army would collapse within weeks, that major Soviet oil fields around Baku would fall to German control, that the resource equation would shift decisively in Germany's favor before the Wehrmacht's limited fuel reserves ran out. Instead, the Wehrmacht found itself fighting across vast distances unprecedented in military history, with supply lines stretching across thousands of kilometers of primitive roads, single-track railways, and territories controlled by partisan forces. Every advance stretched those supply lines further, making each liter of fuel more difficult to deliver. The distances involved boggled imagination. From Germany's eastern border to Moscow, 1,600 kilometers, to Stalingrad, 2,900 kilometers, to the Caucasus oil fields, 3,200 kilometers. Every kilometer required fuel to traverse, fuel to supply the forces advancing, fuel to maintain the supply trucks themselves. German logistics officers, trained in the precise staff work that characterized Prussian military tradition, calculated fuel requirements with mathematical precision. A single Panzer division operating at full intensity needed approximately 30,000 gallons of fuel daily to move its tanks, fuel its reconnaissance vehicles, power its half-tracks, supply its support trucks, and maintain mobility. Multiply that by dozens of divisions spread across the Eastern Front. Add fuel requirements for the Luftwaffe's eastern operations. Include logistics trucks that themselves consumed fuel to deliver fuel, and the scale of the crisis becomes apparent. The entire Eastern Front required millions of gallons weekly, delivered across distances and through conditions that made supply a nightmare even without enemy interdiction. The German logistics system performed miracles of improvisation and efficiency. Logistics officers hoarded supplies, concealed reserves from higher commands who might requisition them, established hidden dumps, and developed elaborate informal networks of barter and exchange. None of it was enough. The system devoured its own capacity. Fuel trucks consumed fuel to deliver fuel to units that needed fuel to justify the consumption of fuel to deliver fuel. The circular logic of logistics under scarcity created impossible situations where moving fuel to the front consumed so much fuel that the net delivery approached zero. By late 1943, as Soviet offensives pushed German forces westward, as Allied bombers ranged deeper into Reich territory with growing impunity, as the strategic situation deteriorated on every front, the fuel situation approached genuine crisis. German commanders looked at maps showing Soviet advances and knew that inadequate fuel, not inadequate courage or weapons, would determine the outcome. The noose tightened around Germany's fuel infrastructure, and everyone understood what that meant for the war's trajectory. The stage was set for catastrophe. Germany had gambled everything on quick victory, on seizing enemy resources before its own ran out, on technological solutions to strategic problems. The gamble had failed. The resources remained beyond reach. The technology proved vulnerable, and 1944 would bring the reckoning. Why Germany lost. The 1944 oil crisis and logistics failure. Part 2. The collapse begins. May 1944 marked the moment when Germany's oil crisis transformed from serious to catastrophic, from manageable to existential. The turning point came not from a single devastating blow, but from the systematic, relentless application of Allied air power against the Reich's vulnerable fuel infrastructure. The campaign had a name, a plan, and a ruthless logic. Operation Pointblank's oil phase. The target list was specific and comprehensive. Synthetic fuel plants, refineries, storage facilities, distribution networks, and transportation infrastructure. Everything that produced, processed, stored, or moved petroleum became a priority target. The first major raid struck on May 12, 1944. Waves of American B-17 flying fortresses, escorted by long-range P-51 Mustang fighters, hit synthetic fuel plants in central Germany. The Leuna synthetic fuel works near Merseburg, one of Germany's largest and most important facilities, took severe damage. Bombs cratered production facilities, destroyed distillation equipment, ruptured high-pressure vessels, and killed experienced workers who could not be easily replaced. Damage assessment photos showed fires burning, structures collapsed, and critical machinery exposed to the elements. Yet the damage, while significant, proved repairable. The Germans had anticipated attacks on their fuel infrastructure and prepared accordingly. Repair crews rushed to the damaged sites, worked around the clock in shifts that stretched human endurance, cannibalized equipment from less critical facilities, and managed to restore partial production within 2 to 3 weeks. Engineers performed miracles of improvisation, welding together damaged components, rerouting systems around destroyed sections, and compensating for missing equipment with manual labor and ingenuity. Then the bombers returned, and returned again, and kept returning with mechanical regularity. This was the key to Allied strategy, not single devastating strikes, but sustained pressure that prevented recovery. Every time German engineers repaired a facility and resumed production, Allied bombers appeared overhead again. The cycle became predictable and hopeless. Damage, repair, brief production, renewed attack, fresh damage. German repair crews found themselves in an endless race against destruction they could never win. Albert Speer, Reich Minister of Armaments and War Production, later described May 1944 as the moment Germany lost the war. Not because of a single catastrophic military defeat, not from one battle lost or one city captured, but because the fuel crisis transformed from a serious logistical challenge into an insurmountable strategic catastrophe. Speer understood production systems intimately, having overseen Germany's remarkable industrial expansion despite Allied bombing. He recognized immediately that the oil campaign was different, more dangerous, more effective than previous bombing strategies. The statistics tell a story of cascading collapse. In April 1944, Germany produced approximately 175,000 tons of aviation fuel from all sources: synthetic plants, Romanian refineries, and scattered minor facilities. This represented nearly full capacity, the culmination of years of industrial investment and expansion. By June 1944, barely 6 weeks into the sustained Allied bombing campaign, production had plummeted to 50,000 tons, a decline of more than 70%. Production continued falling through the summer. By September 1944, Germany managed to produce only 10,000 tons of aviation fuel, representing a catastrophic 94% reduction from April levels. The Luftwaffe, which had terrorized European cities during the Blitz, which had supported lightning advances across Poland and France, which had nearly won the Battle of Britain, found itself grounded not by enemy fighters, but by empty fuel tanks. Experienced pilots sat idle. Advanced aircraft remained parked. Air superiority, once contested, became Allied monopoly. Synthetic fuel plants proved catastrophically vulnerable to precision bombing. The entire hydrogenation process that converted coal into usable fuel required extraordinarily complex equipment operating under extreme conditions: high pressure, high temperature, precise chemical ratios. The system's sophistication became its weakness. A single well-placed bomb hitting a critical component, a high-pressure vessel, a distillation column, a catalyst chamber, could shut down an entire facility producing thousands of tons monthly. Unlike conventional factories where damage to one section still allowed partial operation, synthetic fuel plants operated as integrated systems where everything had to function for anything to function. Repairs took weeks or months under ideal conditions, assuming materials and skilled workers were available. But conditions were far from ideal. Allied bombing had disrupted supply chains for replacement parts. Specialized equipment manufacturers had been bombed themselves. Skilled workers were being conscripted for military service or killed in air raids. Even when replacement components could be fabricated, transporting them to damaged plants became increasingly difficult, as Allied fighters strafed trains and bombed railroad yards. Ploiești, Germany's petroleum lifeline, faced similar systematic assault. American bombers flying from newly captured Italian bases brought the Romanian oil fields within range. Operation Tidal Wave, launched on August 1, 1943, represented the first major attempt to destroy Ploiești's refineries. The raid cost American forces heavily. 54 bombers lost, hundreds of crew killed or captured, but demonstrated conclusively that Ploiești was attackable despite its distance and defenses. Subsequent raids continued through 1944 with increasing effectiveness as Allied air forces gained experience and improved tactics. Romanian refineries, like German synthetic plants, proved vulnerable to precision attack. Refinery equipment was delicate, expensive, and difficult to repair. Cracking towers, distillation columns, storage tanks, all represented critical points of failure. Each successful raid reduced Ploiești's output, tightening the noose around Germany's fuel supply. Then came the strategic catastrophe that ended any hope of German recovery. In August 1944, as Soviet armored forces approached Romania's borders, the Romanian government conducted secret negotiations with the Allies. On August 23, 1944, Romania executed a dramatic reversal, overthrowing its pro-German government, arresting Nazi officials, and joining the Allied cause. Overnight, Germany lost access to Ploiești's entire production, roughly 10 million barrels annually, more than half of Germany's total oil supply from all sources. The impact rippled instantaneously through every level of German military operations. Logistics officers recalculated fuel budgets and found them impossibly negative. Unit commanders received allocation orders showing fractions of previous fuel deliveries. Training programs were canceled entirely. Operational planning became exercises in futility when available fuel couldn't support even defensive operations. The Luftwaffe's collapse illustrated the crisis with particular clarity. German aircraft production actually increased through 1944, with factories delivering thousands of advanced fighters despite Allied bombing. The Focke-Wulf FW-190 and Messerschmitt Bf-109, proven designs continuously refined, rolled off assembly lines in impressive numbers. Yet these aircraft sat unused at airfields across the Reich, lacking fuel to fly and pilots properly trained to fly them. Pilot training suffered catastrophic degradation due to fuel shortages. In the early war years, Luftwaffe pilots received comprehensive training, totaling 200 to 400 flight hours before entering combat. By 1944, replacement pilots might receive 30 hours of flight time, sometimes less, before assignment to operational units. They arrived at the front with minimal experience in their aircraft, inadequate gunnery training, poor formation flying skills, and almost no combat tactics instruction. Facing them were Allied pilots with hundreds of hours of training and often significant combat experience. The outcome was predictable and brutal. The famous Messerschmitt Me 262 jet fighter represented German technological sophistication and desperation in equal measure. This revolutionary aircraft flew faster than any Allied fighter could match, mounted devastating 30mm cannon firepower, and incorporated advanced aerodynamics. Production reached several hundred units despite bombing raids and resource shortages. Yet chronic fuel shortages meant most Me-262s never flew combat missions with any regularity. They sat at airfields, technologically impressive and operationally useless, monuments to capability without capacity. German tank forces suffered equally devastating fuel constraints. The Panther and Tiger tanks were formidable weapon systems, superior in many respects to Allied armor. The Tiger's 80mm gun could destroy any Allied tank at ranges beyond effective return fire. The Panther combined excellent armor protection with mobility and a powerful 75 mm gun. German armor frequently achieved favorable kill ratios in direct combat. None of this mattered when the tanks couldn't move. The fuel consumption of German heavy armor was prodigious. A Tiger tank achieved approximately 0.5 miles per gallon under favorable conditions, paved roads, moderate speeds, no combat. Cross-country operation, the reality of armored warfare, reduced this further. A Panther managed perhaps 0.8 miles per gallon. Combat operations, with constant maneuvering, maximum speed bursts, and engine stress, consumed fuel at rates that made sustained operations impossible with limited supplies. Panzer divisions that had spearheaded the conquest of France, that had driven deep into the Soviet Union, now sat immobile in defensive positions, unable to counterattack Soviet breakthroughs, unable to maneuver to advantageous terrain, reduced to static pillboxes waiting for fuel that would never arrive. Tank commanders watched Soviet forces bypass their positions, knowing they possessed the firepower and capability to intervene, but lacking the fuel to move their vehicles. The Battle of the Bulge in December 1944 illustrated the fuel crisis with terrible clarity. German planners designed the Ardennes offensive, Hitler's last major gamble in the West, around the explicit assumption of capturing Allied fuel supplies. The attack plan literally depended on seizing enemy fuel depots within the first days of the offensive. German armored formations were given enough fuel to reach their initial objectives, with the understanding that subsequent operations would use captured American gasoline. This desperate strategy, attacking with insufficient fuel in hopes of capturing enemy supplies, reflected how completely the fuel crisis dominated German strategic thinking. When German forces failed to capture Allied fuel depots quickly, when American defenders held key road junctions where fuel dumps were located, when weather prevented rapid advance, entire formations ground to a halt. Tanks were abandoned as their fuel ran out, left by roadsides for Allied forces to examine. Infantry formations that had advanced in trucks found themselves walking back toward German lines. Artillery remained silent for lack of fuel to move it forward. Historians continued debating whether the Ardennes offensive could have succeeded under any circumstances. Allied numerical superiority, air power, and strategic reserves all suggested German defeat was inevitable. But the fuel situation made failure absolutely certain. German armored spearheads, which needed to reach the Meuse River within days, ran out of fuel before achieving even their initial objectives. The offensive, which required speed and momentum, bogged down partly because tanks stopped moving when their fuel tanks emptied. Transportation infrastructure crumbled under the combined weight of Allied bombing and fuel shortages. Germany's synthetic fuel plants and remaining refineries required constant coal delivery by railroad. Millions of tons of coal monthly had to move from mines to conversion facilities. Allied bombers targeted this network systematically. Railroad yards, bridges, locomotives, switching stations, anything that kept the system functioning. Even when plants remained operational, even when repairs were completed, moving fuel to frontline units became increasingly problematic. The German railroad system, once a model of efficiency, deteriorated into chaos. Bombing destroyed bridges faster than engineers could repair them. Locomotives were destroyed or damaged beyond repair. Rolling stock was lost to air attacks. Railroad workers were killed, conscripted, or fled from constant danger. Routes that once moved millions of tons monthly managed only fractions of previous capacity. And every ton of coal or fuel that did move came at the cost of not moving ammunition, food, or other critical supplies. By early 1945, the German military operated on fumes in the most literal sense. Individual units hoarded fuel like gold, hiding reserves from higher commands, who might requisition them for other purposes. Desperate improvised measures became routine, extracting fuel from disabled or destroyed vehicles, mixing aviation fuel with diesel in ratios that destroyed engines but allowed temporary operation, blending low-quality substitutes that reduced performance, limiting all operations to absolute defensive emergencies. The Wehrmacht, which had revolutionized warfare with mechanized mobility, found itself reverting to modes of operation from previous centuries. Horses replaced trucks for supply transport. Infantry walked distances that motorized formations once covered in hours. Artillery that couldn't be moved was destroyed to prevent capture. The modern German military dissolved backward through time, abandoning the technologies and tactics that had made it formidable, reduced by fuel starvation to methods that would have been familiar to Frederick the Great's army. Why Germany lost. The 1944 oil crisis and logistics failure. Part 3. The arithmetic of defeat wars are won by logistics, not heroics. This fundamental truth, understood by military theorists from Napoleon to Clausewitz, by staff officers trained in the cold mathematics of supply and consumption, became Germany's epitaph, written in empty fuel barrels and immobilized machinery across a devastated continent. The romantic notions of warfare, courage, tactical brilliance, superior weaponry, all proved subordinate to the prosaic realities of petroleum supply chains, refinery capacity, and transportation networks. The scale of Allied resource superiority was not merely significant, it was overwhelming to the point of absurdity. The United States alone produced approximately 6 billion barrels of oil during World War II. American oil fields in Texas, California, Oklahoma, and Louisiana pumped continuously, supplying not only American forces worldwide, but also providing massive quantities to Britain, the Soviet Union, and other Allied nations through Lend-Lease arrangements. American tankers crossed the Atlantic despite U-boat threats, delivering millions of barrels to European ports. The Soviet Union, despite losing major oil fields around Maikop to German occupation in 1942, still managed to produce roughly 1.2 billion barrels throughout the war. The Baku fields, located near the Caspian Sea and never captured despite German attempts to reach them, continued pumping oil that fueled Soviet tank armies and air forces. Soviet production declined during the worst years of German invasion, but never collapsed entirely, and recovered quickly as Soviet forces pushed westward. Britain, possessing minimal domestic oil production, imported vast quantities from the Middle East, particularly Persia and Iraq, and from Western Hemisphere sources including Venezuela and the United States. British refineries processed millions of barrels annually, the Royal Navy's oil-fired warships, the RAF's thousands of aircraft, British mechanized forces in North Africa and Europe, all received adequate fuel supplies throughout the war despite U-boat campaigns and shipping losses. Combined Allied oil production dwarfed Axis capabilities by orders of magnitude that made German resistance ultimately futile. The arithmetic was brutal. The Allies could replace losses, sustain operations indefinitely, train personnel properly, and stockpile reserves. Germany could do none of these things consistently. Germany's peak wartime oil production, combining all sources, synthetic fuel plants operating at maximum capacity, Romanian imports before Ploiești's loss, minor domestic wells, captured Soviet facilities, never exceeded 60 million barrels annually. This figure, achieved briefly in 1943 before the bombing campaign intensified, represented Germany's absolute maximum potential. Even this maximum fell catastrophically short of actual requirements. 60 million barrels might sound substantial in isolation, but context reveals the hopelessness of Germany's position. The Wehrmacht consumed oil faster than all sources combined could supply it. Every offensive operation drew down irreplaceable reserves. Every training flight burned fuel that could never be recovered. Every truck delivery consumed petroleum that wouldn't be replenished. The German military operated on a downward curve, where consumption perpetually exceeded production, where stockpiles declined monthly, where the end was mathematically certain even if timing remained uncertain. The disparity became even more pronounced when considering combat effectiveness per unit of fuel consumed. Allied forces with abundant fuel supplies could afford comprehensive training programs. American pilots received 400 hours of flight training before combat assignment. Tank crews trained extensively on their vehicles. Infantry practiced with mechanized transport. This training consumed enormous quantities of fuel but produced competent forces that used resources efficiently in combat. German forces, strangled by fuel shortages, cut training to dangerous minimums. Pilots arrived at combat units barely capable of flying their aircraft, let alone fighting effectively. They died quickly, wasting both the fuel used in their brief careers and the aircraft they flew. Tank crews received minimal training on their vehicles, leading to mechanical failures, tactical errors, and unnecessary fuel consumption. The fuel crisis created a vicious cycle where inadequate training led to inefficient fuel use in combat, which wasted the limited fuel available, which necessitated further training cuts. The 1944 oil crisis accelerated Germany's collapse, but didn't fundamentally cause it. Germany's oil shortage was structural, inherent, present from the war's beginning. The crisis merely made visible what had always been true. Germany lacked the resources to fight a prolonged war against industrially superior opponents. Early victories masked this underlying reality, captured Soviet fuel depots, sustained operations temporarily during Operation Barbarossa. Stockpiles accumulated during peacetime years stretched further than pessimists expected. Synthetic fuel production ramped up faster than some predicted. But the underlying mathematics never changed. Every military operation involves precise calculation by logistics officers trained to think in tons, liters, kilometers, and consumption rates. How many tons of supplies per division per day? How many trucks required to deliver those supplies? How much fuel for those trucks? How much fuel consumed delivering fuel? How many trains needed? How much coal to run those trains? How much coal to produce synthetic fuel? The German logistics system performed these calculations continuously throughout the war, watching available resources shrink inexorably against expanding requirements. The Eastern Front alone, by 1943, stretched across 1,500 miles from the Baltic to the Black Sea. Supplying military forces across such distances required thousands of trucks operating constantly in massive relay systems. Each truck consumed fuel. That fuel came from distant refineries and synthetic plants via railroads that themselves consumed coal transported by other railroads. The fuel reached railroad distribution points, was transferred to trucks, which consumed more fuel driving to supply dumps, where it was transferred to unit vehicles, which consumed it reaching the front lines. Every stage of this process consumed resources to move resources, a logistical pyramid where the base had to be exponentially larger than the apex. And every stage was vulnerable to partisan attacks, to Allied bombing, to mechanical breakdown, to simple distance and difficulty. The system required constant expansion just to maintain steady delivery to frontline forces. But expansion required resources that didn't exist. The mathematics were circular and catastrophic. German military doctrine, developed in the interwar years and proven in Poland and France, emphasized mobile warfare, rapid maneuver, breakthrough and exploitation, encirclement of enemy forces, blitzkrieg, the lightning war, depended absolutely on mechanized forces moving faster than enemies could react. This doctrine assumed adequate fuel supplies to sustain high-tempo operations. When fuel vanished, doctrine became irrelevant fantasy. Immobile armies cannot execute mobile warfare. Grounded aircraft cannot provide air support or reconnaissance. Static defense replaced dynamic offensive operations. The Wehrmacht, designed and trained for aggressive maneuver, found itself forced into positional warfare reminiscent of World War I. Tanks sat in defensive positions like bunkers. Aircraft remained grounded. Infantry dug trenches and waited for attacks they lacked fuel to counter. The tragedy, from a purely military analytical perspective, was waste on a staggering scale. Germany produced excellent military equipment throughout the war despite Allied bombing and resource shortages. Factories delivered advanced aircraft, powerful tanks, sophisticated weapons systems, often incorporating technological innovations ahead of Allied equivalents. Much of this equipment never reached full utilization because fuel shortages prevented proper deployment, adequate training, or sustained operations. Consider the numbers that illustrate this waste. Germany manufactured roughly 40,000 aircraft in 1944, the highest annual production of the entire war, exceeding even 1943 totals. This represented a remarkable achievement, given the deteriorating strategic situation, the Allied bombing campaign, and resource shortages. German workers and engineers produced these aircraft under conditions of constant air raids, material scarcity, and labor shortages that would have crippled less determined industrial systems. Yet Luftwaffe effectiveness during 1944 plummeted catastrophically despite record aircraft production. The reason was simple and devastating. Pilots couldn't train properly because training consumed fuel that didn't exist, and operational aircraft couldn't fly sustained missions because operations consumed fuel that couldn't be supplied. Production without fuel meant warehouses and airfields full of unused weapons, capability without capacity, potential without actualization. The tank production story paralleled aircraft manufacturing. Germany produced thousands of Panthers and Tigers in 1944. Sophisticated armored vehicles superior in many characteristics to Allied tanks. These vehicles incorporated sloped armor designs, powerful guns, advanced optics, and refined engineering. They sat unused in depots or were delivered to units that couldn't employ them effectively due to fuel shortages. A Tiger tank without fuel was merely an expensive pillbox. A Panther that couldn't maneuver was a static target. The Wehrmacht's final major offensives all failed partly or primarily due to fuel shortages that prevented sustained operations. The Ardennes offensive in December 1944, already discussed, collapsed when captured fuel depots remained in American hands, and German formations literally ran out of fuel kilometers short of their objectives. Operation Spring Awakening in Hungary. During March 1945, Germany's last major offensive operation stalled similarly when fuel exhaustion prevented exploitation of initial tactical successes. Even tactical withdrawals, the basic military operation of moving forces away from enemy pressure, became difficult or impossible when vehicles lacked fuel to move. German units in 1945 frequently destroyed equipment they couldn't evacuate. Tanks were blown up by their crews. Artillery was spiked and abandoned. Trucks were set on fire. Military hardware worth millions of Reichsmarks was destroyed not from enemy action, but from inability to move it due to fuel shortages. By April 1945, Germany's oil production had effectively ceased to exist as a meaningful military factor. Allied bombing had destroyed most synthetic fuel plants beyond any possibility of repair. The facilities at Leuna, Pöhlitz, Brooks, and other major sites lay in ruins, their complex equipment smashed, their skilled workers dead or dispersed, their supply chains severed. Romania was lost, its oil flowing to Soviet forces. Remaining stockpiles within Reich territory measured in days of supply, not weeks or months. The Wehrmacht fought its final battles with transportation methods that would have been familiar to armies of previous centuries. Horses pulled artillery and supply wagons. Infantry marched on foot across vast distances. Officers rode bicycles. Fuel for vehicles was reserved for absolute emergencies, used sparingly in tiny quantities, hoarded desperately against final defensive needs. The modern German military dissolved backward through technological time, abandoning the mechanization and mobility that had characterized its earlier victories. The lesson extends far beyond World War II's specific historical circumstances. Modern militaries remain utterly dependent on petroleum and its derivatives. Precision-guided weapons, advanced sensor systems, sophisticated communications networks, professional training programs, all become irrelevant without the logistics infrastructure to support them. Fuel is the literal lifeblood of contemporary military forces. Without it, the most advanced military becomes immobile, ineffective, eventually helpless. Germany's defeat resulted from multiple reinforcing factors. The Soviet Union's massive population provided endless manpower reserves and relocated industrial capacity, produced tanks and aircraft in quantities Germany couldn't match. Allied strategic bombing, beyond the oil campaign, destroyed cities, factories, and transportation networks. Hitler's strategic blunders, declaring war on the United States, invading the Soviet Union without defeating Britain, refusing tactical withdrawals, all contributed to eventual defeat. The moral bankruptcy of Nazi ideology alienated potential allies and guaranteed fierce resistance from occupied populations. But underneath these factors, beneath the battles and campaigns and strategic decisions, lay a simpler mathematical truth that logistics officers understood from the beginning. Germany couldn't fuel its war machine adequately. The Reich entered the war with inadequate oil resources, gambled desperately on quick victory before logistics limitations became binding constraints, and lost that gamble in the frozen outskirts of Moscow and the summer fields before Stalingrad. Everything that followed was arithmetic. Terrible, inexorable, unforgiving arithmetic. Production minus consumption equaled a negative number that grew larger monthly. Reserves minus requirements produced deficits that couldn't be covered. Supply divided by demand yielded ratios that declined towards zero. The fuel crisis didn't merely contribute to Germany's defeat. In fundamental ways, it was Germany's defeat, expressed in barrels and gallons and liters, manifested in empty fuel tanks stretching across a continent, written in the immobile armor and grounded aircraft and static positions of a military designed for mobility, but starved of the fuel that mobility required. By May 1945, when Germany surrendered unconditionally, the fuel crisis had become almost a historical footnote. There was no fuel because there was no Germany left to need it. The tanks were destroyed or captured. The aircraft were burned in their hangars or shot down in futile final missions. The factories lay in rubble. The refineries were smoking ruins. The synthetic fuel plants were demolished beyond recognition. The oil crisis didn't just contribute to Germany's defeat. It was the physical manifestation of strategic overreach, the mathematical proof that industrial capacity matters more than tactical brilliance. The demonstration that wars are won by logistics officers calculating fuel deliveries rather than generals planning brilliant maneuvers. Germany lost because it couldn't solve an equation where one side would always be smaller than the other, where consumption would always exceed production, where the end was written in the basic arithmetic of petroleum supply and demand.